Hello there, welcoming all in the physics arena by Nitish sir. Children, today in this video lecture we are going to derive the differential equation of simple harmonic motion. Children, as we are knowing that when a body is at its rest position, then let us suppose that a body is at rest position. So with the help of a simple pendulum we are going to derive the differential equation of the simple harmonic motion. Children, when there is time t is equals to 0, then the body will be at rest. When time t will be 0, then the body will be at rest. So there will be no displacement from its mean position. So the displacement will be 0. Children, let us suppose that if a force is applied, if an external force is applied onto the body, then the body will start to displace from its mean position. Due to the application of the external force, the body will start to move about its mean position. So children, as we are knowing that due to the elasticity, the body will try to regain its original position. It means that a restoring force will be developed at that particular instant, and which will try to bring the body into its mean position. So what I have said over here, that let us choose a body of mass m, gets displaced from its mean point or from its mean position due to application of an external force. So children, due to the elasticity, it will try to, what I am writing here, due to elasticity, a restoring force will develop which will try to regain its initial position. So children, which will try to regain its original position, it means that it will try to move the object towards its mean position. So children, in this condition, according to the Hooke's law of restoring force, so according to the Hooke's law, what we can say that, so what I am writing over here, that according to Hooke's law, the deforming force F will be directly proportional to the displacement from its mean position, but in the opposite direction, children. Okay, so what we can say that if the restoring force is directly proportional to the displacement but with the opposite direction, so after removal of this proportionality we will find out a proportionality constant. Let us suppose that is k, and here we are writing that is y. So children, here the displacement is directly proportional to the deforming force but in the opposite direction, so we can write over here that F is equals to minus of ky. Okay children, where k is also known as a constant of proportionality. Okay children, and where y is known as the displacement. Children, as we are knowing that the body is getting displaced from its mean position due to the external force, so under the influence of the restoring force, it will acquire the velocity v. Okay children, so under the, what we can say that, under the influence of restoring force, body may acquire, under the restoring force, body will acquire a velocity v. So children, velocity can be find out if the velocity of the body is v during the simple harmonic motion, then we can say that velocity can be written as that is a change in the displacement with respect to the time. Children, here dy denotes the change in the displacement and dt denotes that the change in the time. So children, if we are knowing the velocity, so if we differentiate, because as we are knowing that acceleration is nothing but that is what? That is a change in velocity. Acceleration is nothing but that is a change in velocity with respect to time. So children, from here what we can say that instead of writing d of dt, instead of writing v, we can write that is dy upon dt. So children, collectively we can say that is d2y upon dt square will be the acceleration for the simple harmonic motion. If a body is under the simple harmonic motion, then it will have the acceleration is d2y upon dt square. And children, according to the Newton's second law, okay, according to the Newton's second law of motion, Newton's second law, what we can say that is the applied external force, that is F is equals to m into a. So children, F is equals to m into a. So what we can write that the external force F will be equals to m, and here from here we can say that from, let us suppose this is equation number 2. So from equation 2 we can say that A is equals to d2y upon dt square. Okay children, so right now we are getting here that F is equals to m d2y upon dt square. Let us suppose this is equation number 3. So here we have find out that d2y upon m into d2y upon dt square is equals to F. Children, we have now we are going to collect these two information from equation number 1 and 3. From equation 1 and 3, what we can conclude, because the LHS of these two equations are equal, so its RHS will be also equal. So m d2y upon dt square, it should be equals to minus of k into y. It should be equals to minus k into y, children. And children, from here what we can say that, from here we can say that is m, that is only d2y upon dt square will be equals to, let's put m to this side, that is minus k by m into y. Children, why we are putting m here? Because k is also proportionality constant and m, that is the mass of the body, is also a constant term. So what we can say that instead of writing minus k upon m, we can write that is omega square. So children, find out that d2y upon dt square is equals to minus k by m into y. So children, instead of writing k by m, what we can write, that is, since k by m can be written as that is the omega square, children, we can write that is minus k by m is equals to omega square. So now put this into this equation, that we can obtain as d2y upon dt square will be equals to minus omega square into y. So children, from here we can find out that d2y upon dt square plus omega square y will be the is equals to 0, will be the differential equation of a body which is executing the simple harmonic motion. So children, here y is given as the displacement of the object. So you can also write this equation into the terms of x, that is d2x upon dt square plus omega square x is equals to 0. So both the equations, what I am writing here, both the equation both equation represents simple harmonic motion executing by the body. So children, till here we have calculated the differential equation, the simple harmonic motion of a body. So if the displacement equation has been given to you inside of a question, then you can easily find out that whether that body will execute simple harmonic motion or not. So children, keep on watching. Have a great day.